Here's 2015 question 3. It's looking like a Riemann sum table problem, okay? So let's jump into it. Here's part A. Use the data in the table to estimate the value of v prime of 16. So remember, if we have the function, we can find the derivative very easily. But we only have a table, so we have to estimate it by picking 2 points that are closest to 16. In this case, it's going to be 12, 200 and 20, 240, okay? Pretty much slope here. So y2 minus y1, I'll direct you to the scoring guidelines there, okay? You can leave it there. Notice how they didn't really ask you for units, so don't follow the scoring guidelines too literally. Sometimes they give you more than what you need, okay? Equal is equal there. I wouldn't even write the beginning part just to play it safe, okay? Here's part B. So they want us to explain the meaning of this in the context of the problem. So let's talk about that, okay? Right away, I know that v is velocity, okay? And when I take the absolute value of velocity, I actually get speed, okay? Now, when you integrate speed, do you guys remember what that gives you? When you integrate speed, when you ignore direction, you're just talking about distance, total distance, okay? Now, if there wasn't an absolute value around velocity, you would just be talking about displacement, okay? So there you go. From 0 to 40 is the total distance that she jogs, okay? Notice how it says using correct units. So if you want to talk about how far someone jogs, you're just talking about length in units. So in this case here, they used meters. You wouldn't say meters per minute because then that's a rate, okay? So this is the total distance that she jogs in meters over the course of 40 minutes, okay? Here's the second part to that problem here. Approximate the value using a right Riemann sum with 4 subintervals, okay? So if you look at the integral here, we're actually going from 0 to 40, so we're using the whole table. So basically, a right Riemann sum, here we go, is base times the height, we're going to use the right endpoint, plus base, in this case is 8, times the right endpoint, 240, plus 4 times. Now, here's the tricky part. You see how there's an absolute value there? That means all velocity turns positive. So a lot of people would write negative 220 here. Make sure you guys understand that this is a positive 220. Very tricky. And here's the last one, 16 times 150. Leave it equals equal. You should get a lot of points there, okay? But watch out for this right there. Here's part C. They introduce Bob. Bob is riding his bicycle, and they give us his velocity. Okay? So, find the acceleration. Okay? So, pretty much you need to find the derivative, and you need to plug in 5. Okay? So, here we go. The derivative of t cubed minus 6t squared plus 300 is 3t squared minus 12t. And then you plug it in. So that'll be 5 squared minus 12 times 5. That's enough for equal is equal. You're done there. Okay? No need for units because they didn't ask for it. Alright? Here's the last part. Part D. Based on the model B from part C, find Bob's average velocity. Okay. Average velocity. Here you go. You integrate from 0 to 10 of Bob, his velocity, and then you make it an average. That fraction on the outside of the integral is what makes it an average. So here you kind of have to do things by hand. So notice we just take the integral. Okay, t cubed is t to the 4th over 4 minus 6t cubed over 3. They simplified there. That's fine. You don't have to, though. And the integral 300 is just 300t. The moment you plug in your upper minus your lower, you're pretty much done. Leave it there. There's really no need to go that far, okay? That's basically it.